Good afternoon, folks. It's me again. Right, I'm just gonna slog my way through this. This is hard work, man. So it's nice to see Sian and Shuays on the channel. It's good to see you guys. Thanks for coming along. So I'm going to be doing the Edexcel IAL Paper 2. So it's nice to see Sian and Shuays. There we go. Paper 2 from January. I'm doing this as the AS, of course. So I'm going to crack straight on. So let's share screen. And then switch my camera over to my clip cam. Miss Donna still in the background. Just having to listen to my chemistry all day. Poor Miss Donna. Poor Miss Donna. Right. Okay, guys, let's crack on. So I've just finished paper 1. Going to slog through paper 2. I know that you guys find paper 2 harder, and I do understand why. Paper 2 is more challenging. It has a larger portion of chemistry, which is at a slightly higher level, and and chemistry, which is, I would like to say, Sian says hi, Miss Donna.
Hi, Sian.
Yeah. And it's just it contains material which you've not really done before. And so it is just a little bit more challenging. So, okay, I'll crack on. I made a lot of silly mistakes in the paper 1. There was a multiple choice question I just downright refused to do, to be fair. I was just like, I don't even want to spend my time doing that. It gave me a headache. I am not infallible, and I do not pretend to be. I do these papers for 2 reasons. One, because I see the value for you guys, and secondly, it's value for me. It's good for me to have practice doing them as well, especially as a teacher. Okay, so let's crack on with the multiple choice. I'll try and keep track of the sections A, B, and C so I can add the timestamps into the chat. I did record a timestamp for the first one after the multiple choice, but anyway, we'll move on. Okay, so first one, nice reaction profiles, GCSE, not complicated. What is the minimum energy required for the reaction to occur? And of course, this is the activation energy. Sorry, I went too far. That is the activation energy in this graph. So the answer is X. Nice and easy start. I won't do it in green. I'll switch over to red for my answers. There we go. So X is the energy required for the reaction to happen. By the way, in terms of bonds, this is the energy required to break the original bonds. This is the energy released when the new bonds are made. So the overall reaction will be endothermic. And this bit here, all the way down to here, that there is the enthalpy, the overall enthalpy change. Just so you know. Which of these isomers with the formula C8H18 has the lowest boiling point? Add as many branches as possible. So the straight chain has the highest. This one has 1 branch, you can see here. This one has 2 branches, and this one has 3. So the lowest boiling point is C. Nice, easy start. Next. Which of these, by the way, if they ask you why, you would say because the branches reduce the surface area of the molecule, therefore reduces the London dispersion forces. You're done. Which of these pure compounds has hydrogen bonding in the liquid state? So no. No. The reason for this one is because in order for you to have hydrogen bonding, you need the fun. Yeah, you need hydrogen directly bonded to one of these 3. Yeah, so this one doesn't contain nitrogen, oxygen, or fluorine, so it's a no. This one does contain nitrogen, but it's got branches on each one of them, and there's no hydrogen on the end, which means no hydrogen bonding. Hydrogen fluoride, yes. Yeah, hydrogen sulfide, no fun. Next. The hydrogen ion bonds to a water molecule forming H3O+. This is called the hydronium ion. Jensen, good morning. I've got my paper 5 in 2 hours. Any last minute tips? God, paper 5's hard, Jensen. Take your time. Don't rush it. My last paper 5, blimey. My last paper 5, A2 webinars. When was the last time I did a paper 5? There's one down here, I think, somewhere. I did one over Easter. Oh, I don't know where it's going to be. That's irritating. I did all of the June ones. I don't know where they're going to be. It should have just been in exam review webinars. paper 2, paper 5. This is for Jensen since he happens to be here. Jensen, make sure you know that, you know, your benzene facts, your 210 key things, know your transformations. Yeah, I'd probably say if you've got an hour, have a quick flick through my webinar and have a look at some. The longer answers, of course, are going to be the more challenging. Yeah, your azo dyes comes up. That was a mean question, that. Did not like that one at all. Know your colors. Make sure you've gone over your colors. Oh, that was mean. Had F block elements. Grim. That was not fun. The A2 papers are hard. Unit 5 is the hardest paper you'll ever sit. It's tough. Have a look over your colors, Jensen. Make sure you've got your colors down. There's going to be questions on colors, and then small paper 6, really. And your transformations. No, organic transformations. Yeah, that's tricky, that last minute, Jensen. If the video's on your channel, I'll check it out, mate. Yeah, it is. It is on my channel. So I went through the June paper. So if you have a look on my YouTube channel and have a look under, yeah, it is on my YouTube. I don't know what paper they're giving you. They might even be giving you this one. Might be worth having a watch through it. Maybe a double speed might be worthwhile. Go to my channel and go to videos. Then you'll come across the paper 5. There it is. Edexcel IAL June Unit 5 exam review. Have a watch of that, Jensen. The thing is about, I think it's about 2 hours long, but if you watch it at double speed, you'll get it done in an hour. Have a watch. Hope that's useful to you. Let me know. Lob a message on my chat. Just let me know how it goes. Good luck. Let's go back to this one. Okay, back to here. Okay, so a hydrogen molecule, electron pair pulse, right? So we need to work out the shape of the hydronium ion. So the shape of the hydronium ion, H3O+. So our central atom, oxygen in group 6. Add on your attachments, +3. Adjust for charge, -1. 8, 2, 4. So we've got and then we've got a H, and then a lone pair. Yeah, so it's normally 109.5 for 4 bonds, but we've got a lone pair, so it becomes 107. Trigonal pyramidal C. An air bubble trapped in the liquid showing viscosity. Ooh! Which one's going to be the most viscous? Monoalcohol, dialcohol, trialcohol. Ugh. Okay. Hi, Mita. Good to see you. Appreciate it, mate. Thank you. Good luck. So it's either between C or D. And D is a big molecule, probably is going to be quite thick, but it's got no hydrogen bonding, so I'm going to assume C. But that one is of interest of me. That's be interesting. It could be the Van der Waals. But the thing is, though, they can't do that because you can't judge. We know that Van der Waals forces, London dispersion forces are cumulative, but you don't know whether or not it beats hydrogen bonding, and that's got 3 hydrogen bonds per molecule. That's going to be thick. It's gonna be like propane 1,2,3 dial. It's gonna be as thick as glycerol. Glycerol's really thick, a very thick liquid. Next, this question is about the reaction of potassium iodide and okay, this is group 7. So the iodide ion is the most powerful reducing agent. So the sulfuric acid, if you add conc sulfuric to Ki, what happens is you get poof, misty white smoke. Or misty fumes of HCl, followed by KHSO4, which we don't see, followed by bubbling of sulfur dioxide, followed by a yellow solid of sulfur, followed by black iodine, followed by a bad egg smell. So we've got everything's going on with iodine. So which one would you not see? Misty fumes? Yes. Black solid iodine? Yes. Yellow solid sulfur? Yes. Dense white smoke? No. The change in oxidation state from sulfur to H2S. So we're going from H2SO4, H2SO4 to H2S. So we start off with the oxidation state, -8 +2, sulfur's +6, minus +1 or +2, because there's 2 of them. That's be -2. So it's gone from -2. So we've gone from +6 to -2. We've gone down by -8. Seems reasonable. Oh, okay. Balancing equations using redox. Okay. That's a bit more tricky. So what the first thing I'm going to do is I'm going to isolate the iodine. So the iodine goes from iodate 5 ions to iodine. Let's balance the half equation. 2 iodines plus water, 6 of them, plus 12 H pluses. Holy moly, that's a lot. And then plus 12 minus 2. So that's overall plus 10 electrons, because that side's 0. Bring it down, okay? Next, I'm going to isolate the sodium. So I isolate the sodium for the sulfur. There's the sulfur. Yeah, so the sulfur is S2O6 2 minus going to SO4 2 minus. Balance for the sulfurs. Balance for the oxygens. 8 plus H2O, 2 of them, plus 4 H pluses. Right, 0 minus 2 minus 2 minus 4 plus 4. Oh, that's interesting, isn't it? Yeah, it's all looking so far. So that's 0. So we need to add 2 electrons to that side. Right, now I need to multiply them to add them together. I need 10 so times by 5 to get me to 10 electrons. Gets me to 5 times 4 is 20 H pluses. Gets me to 10 of those. Gets me to 5 of those. And then to 10 of those. So all of those vanish. And 4 of those are left. And then the electrons disappear. H pluses disappear. Leaves me with 8. Right. Final answer. Final equation. I'm just swapping over to black again. Final equation. 4 H2Os plus 5 S2O6 2 minus plus 2 iodates goes to 1 iodine plus 10 SO4 2 minuses plus 8 electrons, 8 protons, and we're done. So yeah, iodine, yeah, that all adds up. So the X for the iodate is 2. They're all 2. That needs to be a 2. The Y for the S2O6 2 minus, the thiosulfate ion. Is that the thiosulfate ion? Could be. S2O8. It's going to be 5. Yeah, so we're now down to C and D. And then the Z is 10. So the answer is D. Not nice. Not nice whatsoever. Next. Magnesium reacts with hydrochloric acid. Which statement about this reaction is correct? Magnesium atoms act as an oxidizing agent. It's oil rig. Metals lose, agents gain. So is the agent gaining electrons? The magnesium's losing electrons because it's becoming 2+. So that is not correct. Hydrogen molecules act as a reducing agent. It's not even an agent. It's on the wrong side of the equation. So that's not right. Hydrogen ions act as an oxidizing agent. They are hydrogen ions. And a oxidizing agent gains, it is going from H plus to H2. It is gaining electrons, so it is an oxidizing agent. And the chloride ions aren't doing anything. Which of these compounds do not produce a color in a flame? Well, that one doesn't. That one does, orange, red. That one does produce no color on a flame test. Which one is an alkali gas when warmed with sodium hydroxide? Ammonium. So the answer is C. That much time. Yeah, but remember, Shazza, you need to remember, some of these are quick and some of them take more time. You can't rush them. You just have to get used to some are quick and some are more challenging. Yeah, that one took me all of 1 second. I knew my tests. I get it. I move on. Which of these increases down group 7? Increases down group 7, descending. Oxidizing ability of the halogens. The most powerful oxidizing agent in the world is fluorine. So it is not that because it decreases down the group. Reducing ability of the halides. The most powerful reducing agent is iodide. That one is the answer. Electrostatic attractions between the nucleus and the outer shells increases? No, it's getting further apart. It's definitely not right. Electronegativity of the atoms increases down the group? No, fluorine is the most electronegative. It's definitely B. Moving on. Oh my God. Yeah, you're right. Shazza, this one's going to take a bit of time. Which alkane has a standard enthalpy change of combustion of kilojoules per mole? And they've given us kilojoules per gram. What a nightmare. Okay, so we need to convert kilojoules per gram to kilojoules per mole. So I need to go from grams, and this is number of moles, is grams over rams. That's how I get grams to moles. Yeah, well, this is per gram. Yeah, this is per gram, which means that's 1 gram. Yeah, we've burnt 1 gram of it. So 1 gram, let's do methane first, CH4. 1 gram of methane is 1 over 16. Calculator. So I'm turning it into moles. 1 gram over 16 gives me 0.0625 moles. Right. The kilojoule's already there. So kilojoules per mole. And the kilojoules is 55.6. So 55.6 divided by 0.0625. Total 889.6. Definitely not right. It's nowhere near big enough. Let's go to the next one. Ethane, C2H6. 1 gram over, how much does it weigh? 12 plus 6 over 30. Number of moles, 1 over 30. 0.0333. Right, divide that by 52. 52 divided by answer gives me 1,560. It's not enough. Next, propane, C3H8. 1 over 44. 1 divided by 44 gives me 0.0227. What's the energy output? 50.4. 50.4 divided by answer gives me 2,217. The answer's D because it's none of the rest. If you want me to do it anyway, C4H10, 12 times 4 plus 10, 58, 1 over 58. 1 divided by answer gives me 0.01724. The energy output was 49.6. 49.6 divided by answer gives me 2,877. We're done. That one took time and a lot of space, way more space than I've got. I'd be doing it all over the place. Nightmare. Nightmare. Not even worth the time, really. Right. Hess cycles. I don't like Hess cycles. I despise them. I do everything I can to avoid them. What is the enthalpy change for the dissociation of ethanoic acid to that and H+? Write the equation. CH3, COOH, dissociates into CH3, COO- plus H+. That's what I'm trying to work out. Right, so I need to build this from these. Right, where do I get the ethanoic acid from? I get the ethanoic acid from him. CH3, COOH plus OH minus goes to CH3, COO- plus H2O. Right, that's just given me him and him. And the energy output was minus 56 because I haven't changed it. I haven't flipped it, I haven't done anything to it. Now I need to get rid of him and him. Yeah, and I need him. And I get everything from this equation. Flip it over because I need to reverse it. So H2O goes to H plus OH minus. Flip the energy output, turn it over, plus 57.2. Cancel what cancels. H2O vanishes. H plus vanishes. No, it doesn't. It can OH minus vanishes. Oh, yeah, that's the one I'm trying to create. Yeah, that's perfect. That gives me what I want. Now just add them together. So, brackets, minus 56, close brackets, plus brackets, plus 57.2, because I reversed it. Gives me a change of 1.2 positive. The answer is B. Tricky. Right. What is the skeletal formula of 2-chloro-4,4-dimethyl? 1, 2, 3, 4. No. 2, 1, 2, 3, 4, 5, 6. The answer's B. Yeah, definitely. Because that would be 2, 3, 3. And that's cyclo, it's garbage. Moving on. Some alcohols react with concentrated phosphoric acid to form an alkene. What type of reaction is this? It's a hydrolysis. Yeah. The mechanism would be an elimination. Yeah, but the reaction is a hydrolysis. A difference between a reaction and a mechanism. Next, the structure of 2-methyl-pentanthreol is shown. The alcohol reacts with to form how many different alkenes? Right. So if I eliminate this, yeah, and I drop it down on this side, I'll form the double bond there. Yeah. Alternatively, I could hydrolyze it and it would drop down here. And here's the extra kicker, folks. It's going to be geometrically active. So the answer is going to be 3. I'll show you that, by the way, in picture form. So if I remove that OH group and I drop it down here, the CH3 groups are the same. Yeah, that doesn't show geometrical isomerism. Is everyone okay with that? Because these two groups are the same, one isomer. If I drop it down on the other side onto there, what you realize is there's an invisible H here and a CH3. And then this, of course, is a CH3 as well. So I can get that one, but then alternatively, it could also flip it and be the other direction as well. So if I could also have that bond go up and the invisible H go down. Yeah, so I'm going to get a different, those two are going to be two geometrical isomers. I've gone and lost all my windows. There we go, bring that back. For paper 5, do I need to memorize all the transition metal reactions with sodium hydroxide and ammonia? Man, Jensen, yes, you do. Unfortunately, dude, you kind of do. Like, go through my paper 5, you'll see them. Yeah, just skip through it until you get to the transition metals. You're kind of out of the loop there, Jensen. You're trying to learn the transition metal equations in an hour before your paper. Good luck. Do the best you can. Next. Magnesium nitrate decomposes on heating. What is the total volume of gas formed at room temperature and pressure? When? Okay, so I have 0.005 of that, which means moles as well. I can use the equation. I'm going to get double the NO2, 0.005 times 2, which gives me 0.01 moles of that. And then I'm also going to get half of that with oxygen, 0.005 divided by 2. That's going to be shift eng, 0.0025. Add those together, plus 0.01, gives me total number of moles of gas, 0.0125. Right, number of moles is V over 24,000. I've got the moles, 0.0125. Times it by 24,000 and I'm done. Times that by 24,000 and the answer is 300. I'm done. Thank you very much. Moving on. How many moles are there in 15.1 centimeters cubed of liquid propanol? Oh, nice. Just using density. How many moles? So first of all, we're going to need to get the centimeters to grams. So that's the density. I've got that many, 15.1 centimeters cubed, and each one of those weighs 0.8. So I need to multiply it by 0.8, which will convert it to grams. 15.1 times by 0.8 gives me 12.08 grams. I've been given the MR, number of moles is grams over rams. So I've got 12.08 grams over 60, and I get divided by 60, and I get 0.2. Oh, blimey, that doesn't help me at all. Right. 15.1 times by 0.8 divided by 60. See, we're done. Oh, don't like that. Next. The oxidation of propan-1-ol by acidified potassium dichromate forms propanoic acid with a yield of 36% by mass. What mass of propan-1-ol will be needed to make 37 grams of propanoic acid in this reaction? Right, so we've got propan-1-ol going to propanoic acid, and I want 37 grams of it. It's a 1-to-1 ratio, but it's 36% yield. So that there is 36%. Well, what's 100%? So 37 divided by 36 times by 100. Right, so divide that by 36 and then times it by 100, and I should have made 102.8 grams of it. Right, well, we've got the MR of propanoic acid, which is there. So grams over rams over 74. Divide that by 74, gives me 1.39 moles of it. It's a 1-to-1 ratio, so I need 1.39 moles of propan-1-ol. Propan-1-ol has an MR of 60. Multiply that number by 60 and I get 83.3 D. Moving on. Barium chloride solution reacts with gallium sulfate to form a precipitate of barium sulfate. What is the minimum volume of barium chloride needed to precipitate all the sulfate ions outright? So let's write the equation. So we've got barium chloride reacting with gallium sulfate, gallium sulfate to form barium sulfate and gallium chloride, which is GaCl3. Balance the equation. 1 barium, 2 chlorides, 3. Common denominator is 6. So I'm going to go to 6 and 6. Right, next, 3 bariums, and it all adds up. Right, so what is the minimum volume of barium chloride? So they've given us a concentration of that in moles per dm cubed. I'm just going to write down capital M for molarity. Man, my Mock 3 sucked. Like they gave us a Cambridge paper. Oh no, Cambridge is hard. Meter, they gave you a Cambridge paper when you don't do Cambridge. Is that correct, Meter? I want Meter to reply to that. I know Meter. Meter is one of my, in fact, Meter is my #1 follower. She is always popping in to say hello. They gave us a Cambridge paper. So, Meter, what exam board do you do? Right, Meter, your school's not going to like me very much, but if I'm honest with you, you need to make a complaint. You need to be absolutely 100% sure that they gave you a Cambridge paper, but they should have given you no Cambridge paper questions. In your mock exam, which is being used potentially for your tag grades, your teacher-assessed grades, you need to make a complaint and say that those questions shouldn't have been on there. The problem is there's a bit of a dual personality going on here with me, because I would argue that if chemistry is chemistry, you should be able to do it. But the questions for Cambridge are very, very different. And any experienced chemistry teacher would tell you that Cambridge would have been the last exam board I would have picked. The whole layout's different. It's all very strange. They've done something they shouldn't really have done there, Meter. But just throwing it out there. So I've got 0.1 moles per dm cubed there. The gallium, I had 200 centimeters cubed of 0.05 moles per dm cubed. C times V over 1,000. Number of moles is C times by V over 1,000. So 0.05 times by 200 all over 1,000, and I get 0.01 moles. Right, the ratio is a 1:3, which gives me 0.03 moles. Now I need to rearrange the equation. Number of moles times 1,000 divided by the concentration will give me V. 0. Times by 3 gives me 0.03 times 1,000 gives me 30. Oh, I've made a mistake. What have I done? I've made a mistake there, folks. It's really evil. Number of moles of gallium chloride, 0.05 multiplied by 200 divided by 1,000, 0.01 times by 3. Oh, yeah. All the sulfate ions. Yes, that should work. Yeah, 0.03 times by 3 to get to barium chloride. Now times that by 1,000 divided by 0.1. Oh, 0.1. It's giving me 300. The answer is C. Done. Right, that brings me to the end of the multiple choice. Now I've had a few distractions along the way from various people. I have totally lost my own. Paper 2 is live. I want to see what time it is, you see, that's all. I am currently on. It's not telling me a time. How long have I been going for? 30 minutes. I'm on 30 minutes. I have had a few distractions. Well, this ain't the first time they did this. They did the same thing during our Mach 1. 30 minutes. Had some distractions, but otherwise than that, yeah. Meter, that's actually really, it's actually really stupid of them. Of all the exam boards to pick, I wouldn't ever pick Cambridge. I wouldn't mind mixing Edexcel with AQA. They're very similar, including their layout. But Cambridge is hard. Like, it's harder, really, than the others. It requires more practice on multiple choice. Yeah, tricky, that. I personally think that they shouldn't be asking you questions from an exam board that you haven't done, in my opinion. Certainly. Anyway, ethanol can be made in industry by the reaction of ethene and steam using phosphoric acid catalyst. Oh my God, 6 marks. Oh my God, oh, grim. The reaction is carried out at 300 Celsius, 60 atmospheres. The initial yield is 5% achieved when the ethene first passes through the reactor. Explain the chemical reasons for the conditions used and why such a low yield is acceptable in this industrial process. Right, we're running COFSI all the way through. Blimey, 6 marks. Ugh, grim. Okay, let's do temp first. Temp. The forward reaction. We're running COFSI, by the way, anyone who doesn't know my methods. COFSI. COFSI. Yeah, knowledge. Forward reaction. Forward reaction. I'm just going to actually put COFSI in the gap the way I do it in an exam. I'd do that. COFSI. Forward reaction is exothermic. Exothermic. Lower temperatures oppose. If we reduce temperature, reduce temp, the equilibrium will raise temp, favoring forward reaction, favor forward reaction, shift left to right, increase yield. However, they're using 300. However, 300 degrees is a compromise. Reasonable yield and a reasonable rate. That'll be a mark. We're not getting a reasonable yield, we're getting a terrible yield, but it's reasonably quick. You can just put it back in, that's why it's going to be another point. Next, pressure. Okay, 60 atmospheres, 60 atm. COFSI. Knowledge. Pressure is about particles on either side. 2 moles on the left, 1 mole on the right. Knowledge. 2 moles of gas on left side of equation and 1 mole on right. On right. Oppose. Increase pressure. Equilibrium shifts to reduce pressure, shifts to lower pressure. Favor side with less gas. Favor side with less gas. Side with less gas. Shifts left to right. Shifts left to right. Yield increases. Yield increases. However, 60 atmospheres is a compromise. Since at high pressure, the ethene will polymerize. Next, right, now I need to say why it's accepted to get a 5% yield. 5% yield, okay, due to reusing unreacted gases. They recycle them. You're done. 6 marks will be there. Horrible question. Grim. Next, the production of the reaction is a mixture of ethanol and water. Explain why ethanol and water mix together fully. Draw a diagram. So they form hydrogen bonds together. Here's ethanol. Now, whenever you draw hydrogen bonds, you must draw it to be straight. So I'm going to add on my lone pair here and lone pair here. But what I'm going to do is I'm going to do this. There we go. These two here must be at 180 degrees, just letting you know. Yeah. And then all of your lone pairs and all of your deltas must be shown. There you go. Ethanol forms hydrogen bonds. To water. Hydrogen bonds to water. That's all I'm going to do. Ethanol can be oxidized using a solution of acidified potassium dichromate, orange to green. Ethanoic acid is another organic product. Y are both possible products. Draw the structure Y. So you could also form the aldehyde under distillation conditions. There's ethanol. State the condition needed to maximize the yield of each product. For yield, for this one, we're going to do distillation. And this one, distillation and excess alcohol. This is going to be reflux and excess oxidizing agent. Excess acidified K2Cl. 7. Next. Give the systematic name for A. Where's A? 1, 2, 3, 4, 5. Right, so it's based on pentan-1-ol. No, it's not. Such a trick. 1, 2, 3, 4, 5, 6. It's based on hexan-2-ol. And we've got 1, 2, 3, 4. So we've got 4-methyl. 4-methyl. Oh, no gap. Hexan-2-ol. Done. Identify the name or formula as suitable reagent for step number 1. We want to turn an ol into a chlorine concentrated HCl. Next, give the mechanism for step number 2. Oh, nuke sub with ammonia. So wicked. Love it. Nuke sub with ammonia. I've got to draw the whole thing out as well. That's a nightmare. So 1, 2, 3, 4, 5, 6 chlorine. And then it's on the fourth, which is then here. Boom, add a CH3 on that one. Right, add on your sticks. And yes, just take your time with this, folks. Like, students try to cheat and they make a mess. It's just not worth it. Just take your time. This is 4 marks. This is meant to be 4 minutes. It won't take you that long to do if you know what you're doing. Right, step number 1, find your delta. Delta positive, delta negative. Right, ammonia. I'm going to put it here. NH3, lone pair. Done. Step number 1. 1, 2, 3, 4, 5, 6. Yep. Intermediate. Still counts. Doesn't matter the size. Just as long as I'm taking my time and doing it properly. It's always better to do things properly. Don't think it's going to save you any time to start cheating and writing CH3s and CH2s. Don't do it. Right, another ammonia comes along and acts as a base. There we go. Done. Do I need my product? No. Okay, DMAA is only slightly soluble in water, but dissolves readily in hydrochloric acid to form an aqueous solution. Explain the type of bonding that occurs between the nitrogen atom and the hydrogen ion when the positive ion is formed. It's a dative covalent. Whoops. Dative covalent, or a coordinate bond, whichever one you prefer. One bond. Let's draw a picture. This is going to get me all 4 marks. Yeah, both electrons. That's it. I'm done. I've got to say dative covalent because that's 1 mark, and then showing that both electrons have come from that atom to form that bond. It's totally fine. Oh, don't forget positive charge on the end. So close. Next, complete the diagrams how the ions interact with water. Okay, so a positive ion will attract the oxygens on water. Let's draw, I don't know. Don't need that many, really. H. Then I'm going to show my dipoles. It's 3 marks, this, guys. This is 3 minutes for a diagram. Just take your time. Don't rush it. It's worth the time. Just drawing a nice, easy diagram. This is easy. This is 3 marks, these. Next, negative ions can be attracted to the H's. Done. Well, no. Finished. I'll do. 3 marks. Take it. 3 marks too. Nice. This question is about ethanoic acid and some related salts. A test to confirm the presence of an aqueous acid is added to a small amount of solid sodium carbonate. Describe 2 observations. Okay, white solid vanishes. White solid dissolves. Solid dissolves. / vanish. And it will fizz. Fizzing. Done. Nice and easy. Sodium ethanoate is a component of reusable hand warmers in use A supersaturated solution of the sodium ethanoate recrystallizes to form solid hydrated sodium ethanoate, releasing energy. A hand warmer has a mass of 63.2 grams and forms 20.1 grams of the hydrated ethanoate recrystallized. Calculate the maximum temperature reached by the hand warmer if the original temperature is 5 degrees Celsius. Oh my God. So calorimetry all over the place. So number one, Q equals MC delta T. Step number two, divide by 1,000. What's DMA? Who knows? Who the hell knows? I don't know. Delta H equals Q over N. Shazza, did you watch my paper one review? It had squalene in it, an oil from shark skin or shark liver. Weird. Right, what we're looking for is the maximum temperature increase. So we're looking for this guy. We've been given him. Yeah. We have the mass, has a mass of this and forms. So we have the mass of this guy, 20.1 grams. Yeah. Okay. We need to work out, we've got the enthalpy change, we need moles and we need Q. We can't get to Q. Oh no, but we can find Q with that. Reorganize it. Q equals delta H times N. So Q equals delta H, which is here, minus 119.7 times by the moles. Right, we need to work out the mass, holy moly, of the hydrated crystal. We're going to have to work out the moles of this guy. That's grim. Right, so let's work out its MR. So 12 plus 3 plus 12 plus 16 plus 16 plus 23 plus 18 times 3. Run it all through. 12 plus, calculate one. 12 plus 3 plus 12 plus 16 plus 16 plus 23.0. Was it 0.1? Don't know. Eek. You've got to remember that this is A level. We've got to make sure we're using our thing to 1 decimal A level periodic table. Where's sodium? It's 23.0. 23.0, fine. Plus 23 plus bracket 18 times 3. 136.0. How many people are going to lose the 0.0 on that one? No, I couldn't. We'll check it out later. So multiplied by 19.7. That's going to now give me Q in kilojoules. So that becomes 2,679.2 kilojoules because I put it in as kilojoules. Turn it into joules times 1,000. So 2 million, wow, 79200 joules. Right, now I've got Q in joules. I can now work out the temperature. So I can now go, Q is 2.6, it's nearly 7 million joules. And then we want delta T, so divided by M times C. So that divided by the mass, that a hand warmer has a mass of 63.2. 63.2 grams multiplied by the heat capacity of the hand warmer is 3. So divided by brackets 63.2 times by 3. Go! So I now have a delta T of 14,000 degrees Celsius. Okay, I've made a mistake somewhere. That's really funny. 19.7 times 136. What have I done? I've done something. That's kilojoules per mole. Yeah, times the... Oh, that's not moles. I'm an idiot. There's my mistake. So that's the MR of that. When it tells us we formed 20 grams, so 20 grams over rams over 136. I'm an idiot. 20.1 over 136 equals, that makes more sense, 0.148. Right, that now goes in here, which is 0.1478. Right, times that by 1,000. Times 1,000. It's really funny. 147.8 joules of energy. That makes much more sense. Right, now divide it by brackets. 63.2 times 3. That doesn't make any sense either. I've gone and stuffed something up here, folks. I'm on the right lines now. That was a stupid mistake. Kilojoules per mole, 19.7 times by 0.148. 19.7 times 0.148. I've really stalled myself here, guys. I'm writing down the wrong answers. Q equals 2.9156 kilojoules. Right, now convert that to joules. Right, times by 1,000. I'm just not doing the maths on my calculator. 2,915.6 joules. Right, now divide that by brackets. 63.2 times by 3. Go. And I get 15 degrees rise. Plus 15 degrees. Plus 15.4 degrees Celsius. A bit rubbish that, if I'm honest. Anyway, I hope you followed. I made a real mess of that. Sorry about that, guys. I don't think it's enough. Go from 5 degrees to... No, that's probably about right, actually. Yeah, probably about 15. That's an interesting question now. It's going to be right. Right. Ammonium ethanoate is used to control pH of foods. It can be formed by the reaction of pure ethanoic acid with ammonium carbonate. Caloric is found to be able to be changed for this reaction by completing the Hess cycle. Right, can be formed by ethanoic acid, so CH3COOH liquid. Oh no, whoops. CH3COOH liquid plus ammonium carbonate plus NH4 close brackets 2CO3, and I'm going to form CH3COONH4 plus CO2. Assume that's going to be, it's going to go somewhere. No, that's a positive ion. Ammonium ethanoate. It's really weird. An acid plus a base. Yeah, it's going to fizz. Plus CO2, probably water too. Am I missing stuff? This needs to balance. It needs to balance. It doesn't balance. The ammonias don't balance. I need 2 of those, so I need 2 of those. So I've got 1 carbon, that works out. I'm going to lose 2 H's, so it doesn't form water to boot. That's hard, that, guys. Straight off the bat, trying to build that equation from everything they've given you. It's hard, that. That's a grade AB. Right now, it says the enthalpy of formation of. So the formation is all the elements. So we need carbon solid plus hydrogen gas plus enthalpy of formation. Yeah. And oxygen gas and nitrogen gas. I'm running out here. Plus sodium. No sodium there. We got anything else? Carbon, hydrogen, nitrogen, oxygen. Yeah, that's all. Yeah, that covers all of it. Now I need to balance the equation. I've got 5 carbons. Hydrogens-wise, bloody hell. So 6 plus 4 is 7 times by 2 is 14 plus 2 is 16. 16 H's. Oxygen-wise, I've got 2 times 4. 4 plus 3, 7. So I need 3.5 of that. Nitrogens, 2. So it's done. Right, now I can input my data. Right, so it's a really stupid cycle, by the way. So the formation of this guy, of ethanoic acid liquid is minus 484.5. The formation of this guy is ammonium carbonate is minus 939.9. Oh, by the way, there's 2 of those, so I have to double that one. Next one, building of this thing here, ammonium ethanoate is minus 586.3, and there's 2 of them, times that by 2. And then the formation of carbon dioxide is minus 393.5, just the 1. And then water, which is minus 285.8. Right, what a disgusting Hess cycle. So that way equals that way. So next, so final equation. I'll try and walk you through this as best as possible. So we are going down in this direction, yeah, down here and then up here. Well, these arrows here are against us, but we're trying to work out this question mark. So the question mark equals, yeah, these two blue arrows are against us. So against us minus brackets. I'm trying to make this as clear as I can. Brackets this guy, because that's against us. Minus means against. So that's minus 484.5 times by 2, close brackets. This one here is also against us. This one here is also against us. So that one's then going to be minus, because it's against us. Minus, yeah. And that's be brackets. And that's 939.9, close brackets. Right, now these ones are all with us. These ones over here are all with us. So these are all adds. So this is now going to be plus, yeah, which means with us. I'm just going to write it underneath. Plus brackets. The first one is this bit here. Plus brackets minus 586.3 times by 2, close brackets. This one here is with us. Plus brackets 393.5, close brackets. This one is with us. Plus brackets, got minus 285.8, close brackets. And the equation is, I'm pretty sure, is balanced. Should be. Yeah. So just run that through my calculator exactly as it is. Minus brackets, sorry. Against us, brackets, minus 484.5 times 2, close brackets. Against us, brackets, that's a minus, isn't it? Yeah, it's so easy to forget a minus. Minus 939.9, close brackets. With us, open brackets, minus 586.3 times 2, close brackets. With us, open brackets, minus, yeah, minus 393.5, close brackets. With us, open brackets, minus 285.8, close brackets. So easy to make. The answer is 57. So the answer, question mark, equals, so that just all equals 57 kilojoules per mole. I would have in my real exam have written that all in the space. It's just I needed to be able to see the question, and on my tablet, this is the best way of doing it. So I hope that makes sense to everyone. Seems very reasonable to me. Yeah, fine. Ammonium carbonate is an ingredient in cleaning solutions for camera lenses. There are aqueous solutions which contain no more than 1.8 grams of ammonium carbonate in 100 centimeters cubed of solution. Calculate the maximum concentration in moles per dm cubed in a carbonate in such a solution. Right. Well, okay. We need to get to concentration. Number of moles, we've got grams. Number of moles is grams over rams. I need to get to moles. Yeah, grams over rams. So this is ammonium carbonate. So I've got 1.8 grams over. How much does ammonium carbonate weigh? So nitrogen's 14.0 plus 4, hydrogen's, yeah, plus 12 plus 16 times 3. Go. 78. So over 78 gives me moles. 1.8 divided by answer. 0.0, going to lose my mark. 0.0231 moles of ammonium carbonate. Right, that's in 100 centimeters cubed. So if that's per 100 centimeters cubed, we need to say per liter times by 10. Yeah, okay, sure. Moles per 100 times by 10, which would be 0.231 moles per dm cubed. Because this number here is moles per 100 centimeters cubed as per the question. So we want to get to per 1,000 centimeters cubed, because that is equal to 1 dm cubed, which is the question. So we just need to do the times 1,000 times by 10. Hope that makes sense to everybody. Part B done. Who knows how long it's taken. Part C. Okay. Potassium chlorate 5, crystalline solid, yada, yada, yada. Write an overall equation for the Liebig process. We're just going to combine these guys. So he cancels with him. I think that's it. Nothing else. Oh. Ha. Ha. So we've got 6 Ca brackets OH2s plus 6 Cl2s, that's these guys. Then that side's on the additional line there, yeah. So then plus 2 KCl's goes to, that vanishes because it's a intermediate, 5 CaCl2s plus 2 KClO3s plus 6, because those two combine, plus 6 waters. I'm done. Should all add up. I think it does. Calculate the overall atom economy by mass for the production of potassium. Oh, really? Okay. It's been 59 minutes. Thanks, yeah. Overall atom economy. Wanted MR over total out MR times 100. Okay, so wanted MR is potassium chlorate. So potassium is 39.9 plus 35.5 plus 16 plus 16 plus 16. 123.4, but there's 2 of them. It's the only time we ever do this, times by 2. So we have 2 KClO3s over all of it, all out. Yeah, so this times 100. So this becomes 246.8 because KClO3 is 123.4. So that over. Now I need to do all out. Now the great thing, we've done half the battle here. I've done that. So 246.8 plus 6 waters, 6 times 18, got a lot of water, which is 108. And then I'm going to add it to CaCl2, which is calcium is 40.1 plus chlorine at 35.5 plus 35.5. But then we need to multiply that by 6 times by 6 plus 666.6. Okay, add all those together. It's a terrible atom economy. It's all the calcium chloride waste. Boatloads of it. Nasty. So add that all together. 666.6 plus 246.8 plus 108 equals 1,000. This will be a mark. 1,021.4. 246.8 over answer times 100. I get 24.1%. 0.2% actually. Done. Grim. So stupid. Explain the type of reaction that's taking place using oxidation numbers. Right, calcium never changes. Oxygen doesn't change. The chlorine does. So this is a disproportionation. Disproportionation. Because chlorine starts off as a 0, and then it's going to chloride, which is -1. Yeah, but it's also going to the chlorine and the chlorate, which is actually a plus 5. So disproportionation, since chlorine goes from a 0 oxidation state, oxy state in Cl2 to Cl plus 5, I'll make this really clear, plus 5 oxy state in CaClO3 brackets 2 and to Cl 1 minus in CaCl2. We're done. Crystals of potassium chromate 5 formed also contain some halide impurities. Describe a chemical test in the solution of these crystals to confirm that the impurities are chloride ions rather than bromide ions. Include the expected results. So dissolve sample in distilled water. Add nitric acid, followed by silver nitrate solution. Next, bromide would give a cream precipitate. Chloride would give a white precipitate, a white PPT. These look similar. So add dilute ammonia and white AgCl precipitate will redissolve. Done. Moving on. Oh, blimey, this is long. A 1.52 grams of impure potassium chlorate 5 formed in the liquid was heated until the mass remained constant. Oh, the reaction occurred was the impurities' presence did not decompose on heating. Ugh, don't like that calc. Oh, hang on. Okay, so guys, if we've got a sample of KClO3, but it contains impurities that won't decompose. When we now heat this, we'll end up with the smaller solid of KCl, but we still have an unknown amount of stuff that didn't decompose. What we will also have seen is we will have lost oxygen gas. Yeah, and the equation is a 2 to 2 to 3. Now, the only thing I can absolutely be 100% sure about, the only thing that I can be sure about is the oxygen. It told us the impurities did not decompose. So the oxygen is the only thing I can rely on. 1.52 grams goes to 1.02 grams, but we can now work out the amount of oxygen. 1.52 minus 1.02. So I lost 0.5 grams of oxygen gas. That's the only guarantee I can make. These bits I just don't know about. But the oxygen I do. Now I can do grams over rams. Oxygen weighs 32.0. So divide that by 32.0 gives me 0.0156 moles of oxygen gas. Now the ratio in the equation is a 3 to 2 to 2. Well, we're trying to find out how impure it was, its percentage impurity. Sorry, it's a 2, sorry. So what I now need to do is I need to go from here to here. So divide that by 3. Divide by 3 times by 2. Times by 2. And I now get 0.0104 moles of potassium chlorate. That's how much there was that decomposed. So what I can now do is work out its mass. So potassium chloride is 39.9 plus 35.5 plus 16 plus 16 plus 16, which is 123. So I'm going to multiply this now. Multiply this by 123.4, the MR of potassium chlorate. Yeah, so multiply that number by 0.0104. Go. And I get a mass, so we used a mass of 158. 2 grams. The actual potassium chlorate weighed 1.28 grams. Right, so now we can work out the percentage composition, which is 1.28 grams in the impure solid times 100. So divide that by 1.52 times 100, and I get 84.4%. Moving on. Grim. Don't like that. Give the systematic name for that guy. So that is potassium. Potassium chlorate. Now I need a Roman numeral. K plus 1 Cl question mark O4, which is 2 minus times 4, which is 8 minus. And that's plus 1, which means he must be in a plus 7. So potassium chlorate 7. Next, a student investigates the role of a catalyst in this reaction. Heats a sample of potassium chloride in a test tube with a known mass of insoluble catalyst until the mass remains constant. Mix the content with water, filter the mixture, and rinse with deionized water. Oh, why have I got people messaging? Oh my, leave me alone. Explain how each of these steps in the procedure is needed to show that the catalyst is not used up in the reaction. Ooh. Okay. So step one is important in measuring you want to see that it's not used up. It's grim, that. Step one is important. We can see if the rate of decomposition changed. Increase the rate. Next, mix the content with water. So step two is to remove the soluble products. I need to draw this out, to be fair. Soluble products. And then step 3 removes insoluble catalyst. Oh, stuff off. Go away, people. Step 3 removes insoluble catalyst from solution. Step 4 purifies catalyst, removes. Step 4, oh no, filter mixture and rinse with deionized. Darn it. So step 3 is to remove insoluble catalyst from solution and purify. Step 4, dry it so that you don't weigh water. Measure the mass of the dry solid. Step 5, measure mass so can compare. Darn it. So can compare to original mass. Grim. Gross. Next, explain using the diagram how a catalyst speeds up the reaction. This is EA original. This is EA cat. You're wondering how I would do that. Oh, Mr. Duncan, I'll be back when I've finished work. Watching over. Oh, great. Thank you so much for the streams. How would I do this in my exam? If I was actually sitting the exam, what would I actually write down just with my pen? I'd go, oh, EA original. I'd definitely do that. Original. And then I'd go EA cat. And then I'd be going like this. I think I'd probably do that. I think so. That's probably what I would do. And then 2 marks. Explain using how a catalyst speeds up the reaction. So, catalyst provides an alternative reaction route with a lower activation energy. More particles have the minimum energy to react, so more successful collisions. Done. End of paper. Right, let's mark. Let's mark, folks, let's mark. Okay. Let's mark. Man, it's been tough. It's been a tough morning. Oh, that's paper 1. Oh. Yeah, paper 2. Why did that just do that? Why is it calling it paper 1 when it shouldn't be? That's weird. Don't like it. Anyway, let's have a look. Right, green pen. Question 1, A. Question 2, C. Question 3, C. Question 4, C. Question 5, C. Okay, so yeah, 3 hydrogen bonds. Yeah, fine. D. -8. Go. D. 2, 5, 10. C. Oxidizing agent. Ammonium chloride. Reducing power. Number 10, B. Number 11, D. Number 12, B. Number 13, B. Number 14. Oh, that's so mean. What? It's a hydrolysis? Oh man, 14A. They're saying it's an elimination. Is incorrect, as alcohols do not have a double bond addition, sure. Why is it not C? C is incorrect, as water is a product, not a reactant. Oh, yeah, okay. Yeah. Okay. I take it back. I take it back. Okay. I'll give us, okay, it's elimination. If you're making ene, it's elimination. Yeah, fair enough. Okay. B is B. Oh, shoot. 2. No, hang on a minute. Oh, 3. Oh. Thought I got 2 wrong then. 300? Yep. 16A. What have I gone and done? 60 to, oh, it's bloody maths games. Maths games. I'm just going to put maths. I'll take it. Take it on the chin. 83.3. 300. Okay, on this grim question. Oh, I don't want to spend my time marking this. High temperatures are increased since more particles have the activation energy. However, the compromise reasonable, yield reasonable, and a reasonable, I didn't write the word rate in. Lol. I didn't actually write the word rate. Look. Oh, come on, laptop. It's really struggling, folks. reasonable. Rate, try writing down the actual answer, Tobe. Plus Andy, reasonable, and then just gave up. Nice one. Idiot. Increased rate by providing alternative mechanism. What? Oh, did I not mention the catalyst? Oh, darn it, I didn't. Forgot the catalyst. Blimey, that was a horrible question. Catalyst, forgot. High temperatures, compromise rate and yield. High pressure, more particles same size, lowers, recovers, pass through reactor again. Okay, so I'll probably get 4 for that since I missed the catalyst, so I'll give myself 4, but grim. It's a horrible question, that. I can't even bother marking it, if I'm honest. Hydrogen bonds, they form when mixed together. Ethanol forms hydrogen bonds to water. As both compounds have hydrogen bonds, M1 and 3 can be awarded from the diagram. What was M2? Both compounds have hydrogen bonds. Forces that form are similar in strength. So I need to write down that for the 3rd mark. Stupid. No. Similar in strength. INF strength. Stupid. 2. Aldehyde. Distillation. Why distill? Ethanoic acid, heat under reflux. Didn't even need the rest. 4-methyl hexantuol. Concentrated. Oh, got it wrong. Damn it. Darn it. PCl5. Oh, will they allow it? Allow or ignore just HCl? Oh, sorry, allow concentrated hydrochloric acid. Yes. Whew. Excellent. Mechanism. Cool. Fine. Didn't even need the extractor. Dative covalent, lone pair, allow. Yeah, it's all fine. Yeah. Or TMA attached to the slightly positive atoms of hydrogen. Yeah. There you go. Example of images. White solid dissolves. Made a mess of this calculation though, didn't I? Oh, I've still got it wrong. Oh, did they want the final temperature? Calculate the maximum temperature reached. All I had to do was add those two together. Lol. So I get all but the last mark. 4 marks. But then go, right, what I should have done is done 5 plus 15.4 to give me 20.4 degrees Celsius. Yeah, my bad. It's been a long day, folks. Papers are hard. Top 2, all the Hess cycles. The question is, I got the right answer, 57. That's correct. This is complete with elements, multiples. And the answer is 57. Yay, all 5. There you go, there's the example. 3.5 in the box as well. Oh dear, got it wrong. Oh, darn it. Over 96. Oh, I made a mistake on my MR. My MR's wrong. It's meant to be 96. Darn it. So I'm out because of that. Fine. Lose 2. Can't be bothered. Check your MRs. Ooh, they've simplified it. Could have simplified it. Multiples are okay. 24.2%. 24%? Okay. That's interesting. Rounding error? I've probably picked up a number that's incorrect somewhere. 120. There you go. There you go. I've made a mistake. Oh, I did. Always check your ARs on the periodic table. Potassium 39. I put 39.9 as 39.1. That throws me out by 0.2%. So if I lose that mark there, I get the error carried forward though. Nightmare. Just use the periodic table, guys. Don't do what I do. Disproportionation. 5, 0 to 5. Sorry, 0 to +5 and 0 to -1. Dissolve, sample, add to dilute, add to nitric precipitate forms, dissolve in dilute ammonia. This question was grim. AE 4.0%. Oh, have I done it again? I've used 39.9 again, haven't I? Stop doing it. I've used the periodic table. I'm being so lazy. Pacer, vigilant. I have my Unit 2 exam tomorrow. Well, I'm not doing very well, Sasha, on my Unit 2 paper. Please remember, use your periodic table to find all the ARs. Don't use them from memory. I'm an idiot. It's so irritating. Not that it matters. I get error carried forward because of my one mistake, but it still sucks. Need to learn to be better. Potassium chloride 7. No, this was horrible. This heat till constant mass. Okay, fine. Solid products. That's wrong. Solid product dissolves when in step 2 to remove the soluble products. Rinsing it. Solution will otherwise mass solid when it dries. To remove soluble impurities. Remove soluble impurity. Soluble removes. Removes step 2, removes insoluble catalyst from solution, and then purifies. Yeah, with distilled water, so that it doesn't. So you ensure the masses on the catalyst. Removes water from the catalyst. Measure the mass so you can compare with the original. Yeah. There we go. Activation only labeled number of molecules shown on diagram. Winner. I know. Unit 2s are tough. Not as bad as Unit 5. I had another student appear on my channel who had his Unit 5 today, and he was like, do I need to remember all my colors? And I'm like, oh my God, yes. Yeah, good luck. He'll be fine. Right, guys, I am done bringing back my stop sharing screen. I'm finally done. It's been tough, man. Paper 1 and paper 2 basically right next to each other. Right, guys, I hope you find it useful. I really do. Best of luck with everybody with their exams. I know they are all upcoming. I know this. So all the best. I know that you'll be fine. If you've got any questions, give me a shout. I will re-watch this live. Okie dokie. Sasha, I hope you find it useful. Take care, everybody.